Hello students, today in this lecture we are going to study about motion of the follower, and I am going to take the case for average velocity. So suppose this is a cam, this yellow line represents a cam, this one. So we have displacement, we have three angles here, theta naught, theta r and delta. So what are these three angles? Theta naught is the outstroke angle, theta r is the return stroke angle, and delta is the dwell period. Now we have delta equals to, we have this white circle here, this has a white circle, this is the lowest curvature, this is a circle drawn for the lowest curvature of the cam. And we have theta naught, theta r and delta here, and at this position there is a motor connector. There is a motor connector. So this is how the cam moves. Now stroke can be said as x or y is equals to f of theta. Y is a function of theta. Theta is as the cam rotates with angle theta, then we have displacement of the follower. Here we have displacement of the follower here. Now angular velocity omega is equal to d theta by dt, that we all know, and theta is proportional to time. So as theta increases, or as time increases, theta also increases. Now what is the velocity of the follower? Velocity is simply given by dy by dt. So we cannot, y is a function of theta. You can see from here that y is a function of theta. So we have dy by dt equals to dy by d theta by dt. We can differentiate this as this, and dy by d theta, that d theta by dt, that is equals to omega, and this is omega. This quantity here is omega. Now omega is also dy by d theta, that we have gone, we have known the velocity. Now acceleration. Acceleration A is equals to d square y by dt square, which is equals to dy by d theta whole square, and dy by d theta we know from here we know. So we have dy by d theta is whole square is equals to d omega times dy by d theta whole square equals to omega square d square y by d theta square. So we have known the acceleration. Now the jerk. So jerk is d cube y by dt cube and dy by d theta. We can write this in the form of dy by dt. This should be t here. I will take my eraser. Dy by dt. Dy by dt. Dy by dt we know from here. Dy by dt. That is omega dy by d theta. So all that will become cube. So omega cube dy cube y by d theta cube. That is what is called as jerk. Now follower moving with uniform motion. What are the displacement regarding the follower moving with uniform motion? Then displacement is proportional to theta, x is proportional to theta, v is equals to constant. Because why v is equal to constant? Because we have uniform motion. Uniform motion in itself says that the uh, the velocity should be constant. And if velocity is constant, the acceleration will be zero. Now average velocity is given by, this is the lowest and this is the highest portion. Lowest is the lowest of the uh, cam displacement, and highest is the highest displacement of the follower. Lowest displacement of the follower and highest displacement of the follower. Now time for outstroke, we have T naught equals to theta naught by omega, and V naught average is equals to S by T naught equals S omega by theta naught. So this is what is V naught average. Now time for return stroke, that is theta r equals to theta r by omega, VR average is equals to S by TR equals S omega by theta r. So that is what is called as VR average. VR average is velocity of return in the average of velocity of the return stroke. So we have known V naught average, time for outstroke, time for return stroke. Now what is the displacement? What is the governing equation for displacement? I'll write it down here. So all this is done, or we can say we have to come here, that is a governing equations. Governing equation for displacement. So x is proportional to theta, x is equals to c theta, c is a constant to compensate for the equal to sign, to change the proportionality sign into theta. Proportionality sign to equal, we get a c, and c is equals to x by x naught, x by theta naught, and c is equals to s by theta naught. That is what is the value of constant. So c here is constant. Now displacement is equal to x is equal to s by theta naught, and we have x is equal to s theta naught into theta. That is the governing equation. We had written x is equal to c theta. This has come from here. This x is equal to c theta naught can goes to this, x is equal to s by theta naught. We have got the value of constant, that is s is equal to s, x is equal to s by theta naught into theta. So that is displacement. Now velocity, how we'll get velocity? We'll get velocity by differentiating the displacement by with respect to t. So we have s theta naught by theta, s theta by theta naught equals to s theta by theta naught into d by theta by dt, d theta by dt. We know that this is equals to, omega. So we have s omega by theta naught, and acceleration will be 0 because it is uniform velocity. Since we are in the case of uniform velocity, since velocity also, if you differentiate v, with respect to time t, all this is constant, so we get acceleration to 0. And we if the acceleration is 0, if we differentiate it with respect to t, so we'll get 0. So that is d cube x by dt cube is equal to 0. So the formulas that we have derived today is, v average 1, v outstroke average 1, v return stroke average, then we have displacement, this is 3, or it would be more clear if I just highlight them, I think. Yes. So we have v average, vr average, we have x is equals to s by theta naught theta, and acceleration is equal to 0, and jerk is represented by j, jerk is equals to 0. So all this has been derived in this lecture. So guys, if you have that was all for today, guys. If you have liked the video, please do give a like to the video. Thank you for watching.